This video is going to go over our homework problems on 12.1. So as we get going, we want to remember the formula is base times height equals area. So every time we want to decide what do we have, where does that fit, how can we use our formula. So this tells us that the parallelogram's base is twice its height. So the base is 2 times the height, or I could just say two H's so it doesn't look like an X here. And the parallelogram has an area of 32 square feet. What are the lengths of the base and height? So I know that when I do base times height, that it needs to equal 32. So let's come up with some things we know make 32. So let's list factors of 32. So 1 times what? 2, I'll list the first one. So have you do the second one. So 1 times something, 2 times something. I know 3 can't go in there. 4 can, 5 can't, 6 can't, 7 can't. So see if you can find the other multiples here, the factors when we multiply, that will equal 32. So now, which of these has one of them is double the other. So I'll help you out here with this first one. 1 times 32. Is 1 times 2 32? No. Then those are not the base and the height. So see if you, and remember it says that the base is going to be the bigger number. So our right column here is the base. Our left column here is the height. So find the missing factors, multiply by 2 to see if they're equal. That is your solution for the base and the height. Now it wants to know which parallelogram has the greater area, so more area. So I can see here my base is 1, 2, 3, 4, 5 across. And remember, height always goes straight up and down. So this has a height of 2, so base times height is that area. And this parallelogram has a base of 1, 2, 3, 4, 5, and its height is also 2. So they're both 5 across, 2 up. So they look different. To me, this one looks bigger, but doing the math, 5 times 2 is both 10. So they're actually equal because their base and their heights are the same. So they have the same amount of squares inside of them. Number 3 tells us that a panel in a glass stained window is the shape of a parallelogram and has these dimensions: 5.5 centimeters for the base, 7.2 for the height, and we want to find the area. So we're going to do 7.2 times 5.5. So I chose to put 5.5 on the bottom. 5 is easy to multiply and it's the same. So don't forget your placeholder 0. And then don't forget to move your decimal 2 places. And then our answer will be centimeters squared. So we're going to do the same thing for all of these, or just finding the area. Base times height. Remember, height goes from that perpendicular right angle. Here we have base times height. So we'll multiply by 3 to find that area, inches squared. Number 6 is going to be the same thing. We need to take our base. We need to multiply it by the height. I can see they're actually the same here. So 8 times 8 will give us the area of millimeters squared. And number 7 has a base of 6, a height of 9. So 6 times 9 will tell us the area for number 7 in centimeters squared. Number 8 wants to know which of these has the largest area. So I can see here that base times height is 21 centimeters squared. I can see here 5 times 4 is 20 centimeters squared. So I'm going to let you do the other two. So 4.5 times 4.5, see what that one is. And then this one is 2 times 8, or 2.5 times 8. Do that one and see what you get. And whichever answer is the largest is the quadrilateral with the largest area. So base times height or length times width. Since all of these are 4 sides with parallel sides, just do base times height going straight up. Number 9 tells us that a parallelogram has a base that measures 4.8, so the bottom is 4.8, and its height going up to the other base is 5. So we want to find the area of this parallelogram. So 4.8 times 5 will give us that area there. Number 10 tells us that this has an area of 37 square feet. So I'm going to draw my parallelogram here. 37 is the area. The height, it tells me, so from top to bottom in that right angle is 4 feet. It wants to know the base. So let's go ahead and write down the formula for a parallelogram. Area, so base times height equals area. We know the area is 37. We know the height is 4, and we are looking for the base. B times 4 equals 37. So we want to do the opposite of multiply to get B all by itself. So we're going to divide by 4 on both sides to keep our equation the same. So the 4's by the B cancel out. So we're just left with 1B. So we have 37. And I know that 4 does not go equally into 37. So I'm just going to go ahead and add on a couple decimal places while I'm already there. So we need to see how many times can 4 go into 37. That will equal the base. When I do 4 times the quotient here, that should equal 37. This time we have the base of a parallelogram as half the height. So this time we have a skinny, tall parallelogram. So the base is going to be half of the height. So base equals half the height. We know the base is 6.5. So base is 6.5. So base 6. I'm going to actually write it as a decimal because I like to work with decimals better than fractions. So I'm going to say that this is 6.5. And I know that this is only half of the height. So that means the height is 2 times bigger. So to find the height, we need to, so this is the base. So to find the height, we need to take 6.5 and we need to multiply it by 2 to find the height. Then we'll take that height and multiply it by the base, which is 6.5. And that will tell us the total area. So the height is 2 times bigger. We need to find the height, then do base times height to find the final area. Number 12 wants us to find all of the expressions that are equivalent. So I am going to just find the ones I know for sure. So 6x and 8y's, we cannot put those together. They are not the same. But I can distribute and give those. So this turns into 24 x's and 4 times 8, 32 y's. We have to give to both of them. So 24 x's and 32 y's. That one looks good. So if I do this one, give, give. 3 times 8, and then do 3 times 32. Is that the same amount? Here we have 24 times x, and then 24 times 8. Is that the same? Here we have 8 times 3 x's, and then we'll do 8 times 4 x's, see if those are the same. And our last one, we'll do 2 times 12 x's and 2 times 16 y's, see if those are the same. So we want to check each one. Do they have 24 x's? Does it have 32 y's? Number 13 tells us that 9.1 is not a solution. So we have to show and prove that, and then find the actual solution. So if I put 9.1 as n minus 6.4, see what the answer should be if n were 9.1. So it should not equal 2.61. That is not true. So I can see we need to borrow here. And then we need to find the solution. So first we're saying this is what it should be if 9.1 is the answer. Now we're finding what is n actually. So I can see I want n all by itself. The opposite of minus 6.4 is to add 6.4, and we want to do that to both sides to keep our equation balanced, and we want to line up our decimals. The 6 should go under the 2, and the 4 should go under the 6, and we don't have any hundredths here. So remember, when we're adding and subtracting, those decimals and all of the places have to be lined up. So once we do this, that will tell us what the solution to n really is. All right, and number 14 has 3.4 times 6.25. It just wants to know the value, so we're going to multiply. If I were multiplying, I would put 6.25 on the top, even though it was listed second, because it's going to be a lot easier to multiply by 3.4 because it only has 2 digits. So after you multiply, don't forget your placeholder. And then I notice I have here, oh, I'm still red. Sorry, trying to grab my blue. I have this 4 that's a decimal place. This 5 is a decimal place. And this 2 is a decimal place. So when I'm done, I need to move my decimal 1, 2, 3 times to the left to get my final answer.